Today we are going to talk about two- and three-dimensional shapes to understand four-dimensional shapes. And to do this, we first have to understand symmetries. And this here is a diagonal symmetry, because di is two in some ancient language. I think it's ancient Greek or something. So in a diagonal symmetry, this is very Coxeter-Dinkin. They have incomprehensible diagrams, and I will try to explain these today in a nicer form that you can type on a keyboard. So a diagonal symmetry is characterized by two mirrors. We have mirror 1 and mirror 2. And how you create a shape, a diagon or a line segment on a diagonal symmetry is you put a point somewhere on this plane. And if we put this right in the middle, like this, it gets reflected across the mirrors, but it is still in the middle, and it is a point. So we have in a diagonal symmetry, we can have a point which is right in the middle. So it's a diagonal symmetry. We have two mirrors, and it is smack in the middle, which we indicate by O to O. And this is a Coxeter-Dinkin diagram right there. I will not write Coxeter-Dinkin diagrams because I don't understand them myself. I do understand this notation quite well. So what we can also do is we can move this point along mirror 1 so it gets reflected in mirror 2, and we can move it far, we can move it not so far. But what we are interested in, I think, is if we move it so far that this length is 1. So then we have a line like this. A line like this, which is x to O. And then, of course, we can also move the point along mirror 2. And then we have this. And this is a horizontal line. So, horizontal line is O to X. And this horizontal vertical is just relative to this set of mirrors that I made, because we can move it, and then it's no longer horizontal for the camera, but it is still O to X because it's here. We defined it on the paper, and on the paper this is all still true. Then there is one more interesting thing where we can move it, and we can move it along this mirror, we can move it along this mirror, but we can also move it along this mirror and then a little bit along this mirror, like parallel to this mirror. And what we get then is actually a very interesting shape. I will use different colors because it is reflected around mirror 1. Then it is also reflected, this entire thing, around mirror 2. And then we create the connecting dot. And this is a square, but it is not just a square, it is a square with this symmetry. That's important. It's not a square, because if you put it like this, it's different. And a square, and see, it is all the same. If we put it like this, it's exactly the same, because it's all yellow. So, but for now, we care only about the shape. It's a square, it's x to x. In this symmetry, triangular symmetry. And tri means 3. See, it has 1, 2, 3 mirrors, so it's trigon. But what we had here, we had 2 sets of mirrors and 2 sides. And we actually also want this here. So let's look a bit what happens if we rotate this ball. If we move it along the first mirror, we move it along the first mirror, and then it gets reflected in the second mirror, so that it lies on the third mirror. Then this one gets reflected here, and then we have a triangle like this. So if we move it along the first mirror, we actually have that these mirrors have the point on them, like this. Triangle like this is X3O, and the reflecting mirrors are actually these ones and these ones. We also have the point, which is the same as here, so that's if you put a point exactly in the middle, like this, it is a point. It gets reflected in all the mirrors, but it is in the middle, so it stays a point. Now, we can also move it along the second mirror, and when we do all the reflections now, we get a triangle like this, OTX. And this is actually the dual shape, because on every line, this opposite triangle has a point. See? We can put the ball, we can move it across both mirrors so that it is reflected like this, and with a different color in this mirror. And then we put the balls here, and this one is reflected in this mirror, which is of this set, so it is blue. And here we have 2 gray beams that are reflected here, and then we have the last one is blue. So this is again a hexagon. We write it as x3x, just like this is x2x, but it is not exactly a hexagon, because if we rotate it, it is different, because now this is gray and this was blue. And then we also have the square symmetry, rectangular symmetry. This is for sure the wrong word. We actually want something here that is 4, but this is not it. But I don't know. I think it's called the rectangular symmetry, but this would be nice if it's called this. We have 1, 2, 3, 4 mirrors, a point. So first thing we can have is the point smack in the middle. That's a point, but a point in a rectangular symmetry. So a point is O, 4, O. And then if we move the point along the first mirror, it gets reflected in the second mirror, so it lays on the third mirror, and this length is 1, because we moved it that much. Then it gets reflected on the fourth mirror, then again on the second mirror, and then we connect the dots to create this diamond-shaped square, because it's like a diamond. It's not a square. People sometimes call this a diamond, while it's actually a square. So diamond shape we call X for O. And whether this is X for O or this is X for O, that's just a matter of definition, because we can also rotate the paper like this, and then a square like this is X for O. But now we have it like this. So then we can also move it along the second mirror like this. Then it gets reflected. We do all the reflections and we get a square like this. So a square like this is O for X. And again, this is the dual shape, because on every line where the previous one had it, where every line, the other one has a point. And it is the dual shape because this is an X here, and this is an O where this had an X and an X here. And this is, I think, the most beautiful symmetry because it gives pentagons, and pentagons have a beautiful diagonal. So we have 2, 3, 4, 5 mirrors. Smack in the middle, it is a point. So the point is O5O. We move it along the first mirror. Wah! It gets reflected like this, like this, like this, like this and this. And we have a regular pentagon with the point up like this. So this is X5O. Then we can also move it along the second mirror. It gets reflected and we have the O5X. And I did not explain it in this one, in the square symmetry or the pentagonal symmetry, but you can of course also put it in the middle and then you get a tengon, or you can put this in the middle and then you get an octagon. That is again in the same way not an octagon as this one is not a hexagon, because it has these different colors. And actually it would be nice, for the sake of explaining, also to have 2 different pentagons where this one is blue and this one is a different color, like this gray. But we don't have that because I ran out of magnets.